Hello everyone, welcome back to physics class. In this revisional class, we will study about graphical representation of motion. This is what we are going to revise. Now you know, for a uniform motion, if you draw a graph between distance and time, you will get a straight line. And for non-uniform motion, there is deviation from straight line. Now let's see. Now this is my distance time graph. The time is on the x-axis and distance is on the y-axis. And straight line, that means it is for uniform motion. Now, how to find speed from this distance time graph? Now, for uniform motion to find speed, or when you have to find velocity, what you have to do is choose any 2 points on this line. Okay, so I'm going to choose one this point and one this point. Now, what you have to do? You have to simply draw two perpendicular lines. Like this and like this. Now corresponding to these perpendicular lines, you have to choose values. So this value of distance you have to choose, this value of distance you have to choose. Similarly on time axis, this and this. Okay, let's give name A, B, and this is C and D. So now, what is going to be your speed? It is D minus C, because D is at higher position. So D minus C upon B minus A. So this will give you speed by which this object is moving. So from distance time graph you can find out speed. Now let's say if you have velocity time graph. So from distance time you can find velocity or speed. Then from velocity and time you can find out acceleration. Because rate of change of velocity is nothing but acceleration. Now if suppose you have this type of graph. Now this type of graph means an object is moving with uniform velocity, right? Velocity is not changing. In this case, velocity is not changing with time, your acceleration is 0. Now there are two things. One is uniform velocity, that is uniform, and second thing is uniform acceleration. Uniform acceleration means when your velocity is changing equally in equal interval of time. And uniform velocity means your velocity is not changing. So if I have to draw a graph of uniform acceleration, then in velocity time graph it should be like this straight line. Same like what I have here. In distance time graph, this straight line is representing uniform motion. That is, velocity is changing equally in equal interval of time. In velocity time graph, the straight line is representing uniform acceleration. Okay, because velocity is changing equally in equal interval of time. And same if in velocity time graph, if there is no straight line, there is a deviation from straight line, then that is non-uniform accelerated motion of an object. Okay, this you have to keep in mind. And from this velocity time graph, you can find out acceleration. So, you know there are three equations of motion. Okay, first thing about this equation of motion, they are applicable only for uniform motion, for an object moving in straight line and moving uniformly. Okay, for non-uniform motion, those equations are not applicable. So you have three equations of motions, and now we will see how to derive those equations of motion graphically. So what are three equations of motion? First is V equal to U plus AT. So let's start. Now to find out these equations of motion, velocity time graph we are going to use. So what we will do first is we will draw a velocity time graph. So let's say this is my velocity time graph where this is time and this is velocity. And this is my origin O. Now let's assume an object, it is initially moving with velocity U. So somewhere here you have this velocity U. And then its final velocity is V. So somewhere here you have final velocity V. So if this is my U, this is V. Corresponding, so initially if it is here, then it moves and it reaches here. So I will draw a line. Okay. Now what I will do? I will draw perpendicular line over here. And similarly for you, I will draw a line over here. Okay. And now what we will do, we will give name to all these points. So let's say this is my O, this is A, B, C, this point is D, and this point is E. Okay, now first equation of motion. What is first equation of motion? If I write here, this is velocity in this direction, which is in meter per second, and this is in second, in this increasing in this direction. So let's find out first equation of motion. Now I know what is acceleration. So acceleration, that is A, is nothing but change in velocity divided by time, right? So if you see this graph, what is change in velocity? So initially, if object was here, it is, if you start this object from this point E, it is from point E, it is moving to point C. And if you see change in velocity, that means you have to see at y-axis. That means initially, its velocity is changing from B to C, right? So initially, it is at this point B and then up to C. This is your change in velocity. This whole straight line is representing your acceleration motion with respect to time. Then you have to talk only about change in velocity. You have to see y-axis. So BC is your change in velocity. So I will write BC. And during this motion, what is change in time? From E to B. So EB. So this EB is equal to your OA, which is nothing but, if I take this much of time, O to A as T, so I can write BC as U, and now what is BC? How to write BC? How to find it? It is nothing but AC minus AB. Okay, so BC I can write as AC minus AB divided by, these two are parallel, so I can write this as OA. Now what is A to C? So from 0 to this, parallel, so both are going to be equal. So 0 to D equal to A to C, which is nothing but V. So V minus AB. What is your AB? 0 to U, that is U divided by T. So what I can write, and this is A. So what I can write is A equal to V minus U upon T. So cross multiply, so AT equal to V minus U, or if I take U in this direction, U, so I can write V equal to U plus AT. So this is your first equation of motion. Now let's come to the second equation of motion. I am going to use same graph for second equation of motion. Now I have to find distance. Okay, I have to find distance from velocity and time graph. What to do? Now distance from velocity time graph can be find out by finding this area covered by this line. Okay, so area covered is, if you see area covered, O, A, C, E. This is whole area covered by velocity and time. So I can write distance I am representing here by S letter. So my distance traveled is area of this whole trapezium. If you see, it is in the shape of trapezium. So O, A, C, E. Okay, area of trapezium, that is OAC. One more thing, velocity time graph, the area under this curve will always give you distance in velocity time graph. Now this trapezium I can divide into two shapes. One is triangle, one is rectangle. So area of triangle plus area of rectangle will give me area of this whole trapezium. So let's do it. So S equal to area of triangle. Triangle name is EBC. EBC plus area of rectangle. And rectangle here is ABEO. So ABEO. So now let's do it. Area of triangle EBC. Half into base into height. Base here is EB, which is nothing but OA, which is equal to T. So first I will write half into EB. height is BC. So BC plus area of rectangle is length into breadth, that is OA into AB. So OA into AB. Let's do it. Half. What is EB into BC? What is EB? It is T. What is BC? If you see here, BC is nothing but V minus U. Right? BC क्या था इधर? AC minus AB. That is V minus U. And V minus U is what? If you see here, V minus U is nothing but AT. So I will directly write here AT. OA is T and my AB is nothing but U. So if I just reorganize this, what I will, this is your half AT square plus UT. So this is your second equation of motion, UT plus half AT square. So this is your second equation of motion. Now coming to third equation of motion. Same, this I am going to use. In third, you already know distance covered is nothing but area of trapezium. So here in third, to derive third equation of motion, which is nothing but it is not having t parameter, so I have to remove this t parameter. So what I am going to do is same of this equation I am going to use. Your distance I know is area of trapezium. Now here you have to use area of trapezium. What is area of trapezium? Sum of opposite side into half into sum of opposite side into height. Okay, so here if you see, what will be the opposite sides? Parallel sides. Parallel sides will be UO and AC, right? And your this height is OA, right? So if I write here half into opposite side is my OE plus AC into height. Height is OA. Okay, so S is equal to half. Now you have to find what is O to E. O to E is U. Okay, what is A to C? If you see A to C, it is V. And then OA. What is OA? It is T. Okay. But now what I have to do? I have to remove this T from this equation. I want an equation which should not have this T parameter. So what I will do is again I will use this first equation of motion to remove this T. So instead of T, what I can write? So if you see here this first equation of motion, so you know A is V minus U upon T. So if I just swap this, so T I can write as V minus U upon A. So what I will do here is, instead of T, I will write half into V plus U, or okay, I will write U plus V only, and T I can write as V minus U upon A. So now you have to solve. Multiply this with this. So when you multiply half, I will write here, A I will also take it out. So this is U square minus U square plus V square and plus VU minus VU. So this and this will cancel, and this I can write as V square minus U square upon 2. So finally, if I write this equation, this is S equal to V square minus U square by 2A. Or I can cross multiply this. So if I rearrange this equation, I can write V square is equal to U square plus 2AS. So this is your third equation of motion. So first one, V equal to U plus AT. Second equation, S equal to UT plus half AT square. And third, V square equal to U square plus 2AS. Okay. Now, why this graphical representation of motion is important? Because many questions based on graphs you will see in competitive exams. So you should know how to find out acceleration, velocity, distance from given graph. And in revision part, I am going to give you more of this type of questions. Thank you.